what a feature can be? I know it depends on the data.
GTN, as I mentioned, there are different categories, different topics for the training materials, and we have more than 140 so far. Please go to this statistics and machine learning. Let me share my screen with you. Okay, we are here in the Training Galaxy project. Go to the statistics and machine learning part, and you can see different training materials here. One of them is regression in machine learning. We will start from the regression part. And you can see there's a hands-on here, data sets, a link to the data sets we will use in this hands-on, and workflow. After we finish the training material, you can see your workflow can be generated from the history, and you can compare with this workflow. And if you don't want to follow the steps, you can easily use this workflow in your Galaxy platform to analyze your data, and Galaxy tool, and the instance here, it is for the galaxy.eu, and it is also possible to in galaxy.org as well. So please click on this hands-on part. We will use this training material at the first. The estimation time is 2 hours. And the question is, we want to know a background about the regression and how we can apply regression-based machine learning algorithm. And we are going to solve a real problem. It is, we call it age prediction, and we are going to learn aging biomarkers from the DNA methylation data sets, and using these biomarkers to predict the age. And we will see how we can do this task, and at the end I will show you how you can visualize your result after this prediction. Now let's go to this Galaxy platform. I want to give you a short interview about the Galaxy platform. As I mentioned, you can see the toolbar here. All of the tools can be accessible in this panel. You can search your tool, or you can find it easily in the related category. In our case, we can find most of them in the statistics or in the machine learning part. For example, here you can see in the statistics part, you can see some analysis for the PCA, for the LDA analysis, and some statistical tests related to data analysis. And in this machine learning part, you can see the model prediction, or some hyperparameter search, pipeline builder, ensemble methods, and we will apply some of them for data analysis in this hands-on. And here is the main part. As you see, you can see randomly some information about the Galaxy community, some news. For example, yesterday, no, the day before yesterday, we use Galaxy server to the last update, and 2 days ago, and there are some events in December, in November, and I think we mentioned this event as well. Yeah, here the machine learning bioinformatics in ISCB-LA. So you can find your interested events related to the galaxy, and easily you can register if you like. So in the events in the galaxy you can see, and also it is another URL directly you can go to the events part. So here is the main part, and these steps are the history part, and your data analysis pipeline and steps to analyze your data will be saved and recorded in this history, and I will show you how can you use this history more efficient. At the first step, you should create your new and fresh history. For each data analysis or generally analysis, we should create a separate history for our analysis. So here you can see some icons in the history part. This is a create new history. You can click on it, and it is a fresh history with name unnamed history one. Would you please open your webcam, because I want to see, and if somebody has problem, please just raise your hand. I will stop because it is important. You can follow all of the steps with this training material. If you lost somewhere, it is hard to catch and follow the further steps. So you can change the name of your history. For example, I change it to regression ISCB and just click. So you have created your regression. Sorry, you have created your history now. It's a fresh history, and you should start to load your data, or you get your data from an external sources. Okay, so now you can open the this regression tutorial here, and we will try to follow the steps of this regression. But I won't share this regression part. At the first of this training material, it is a short introduction and brief introduction about the regression. I mentioned in my machine learning, introduction to machine learning parts, but as a quick review, in the regression, you want to predict the real value based on the data. And we have different kind of regressor, and we call this line here as the curve, fitting curve, and we want to fit the best curve to our data. And if we have this curve, then we can easily predict for the new samples or new data. And in linear regression, we are going to find this line, the weights and bias for this line for the linear prediction. What is our use case here, and what is the origin of the data? We want to analyze DNA methylation data sets. In DNA methylation data sets, you will see we have a different biomarkers and age related to these features. Sometimes I talk about terms in machine learning. When I say, for example, features, in our case, there are biomarkers. For each samples, we have different biomarkers and the age related to that sample. And we want to build a model based on these samples to predict the age for some new samples. Okay, so at the first step, we should upload the data to your history, to your platform. Or data that we are using in this training material, it is clean data, so you don't need to do noise filtering maybe, or something missing values. But in your real challenge, you should handle some of these, you should apply some of these algorithms to handle missing values or maybe find the outliers. But here we have a clean data, and I will show you how you can upload data into your history. At the first step, it is in the data upload sessions. There are some links here, as Zenodo link, and you can just copy these links or use the icon above to copy the links. And go here and use this icon here. I click this icon for download from web or upload from disk. So in our case, we use some links. So we want to download from web. But it is possible that you easily choose local files here. If you create your own data sets on your local computer, you can easily choose local files and upload it to your Galaxy history. But in our case, I shared the data with the URL, so you are going to download from the website, another website. So here I select paste and fetch data, download data from the web by entering URLs, paste the three URLs here, and easily click start. Okay, so you can see here the gray jobs for loading or downloading datasets. They are still waiting to run, and now they became yellow. It means they are processing. And after the job finished successfully, you will see the green color. So we are waiting to finish. Okay, they are all green. It's successful doing the job. So we used at the first step an interface to upload your data. It is usually the first step of your data analysis. Here, sorry,
I have some issues. I'm sorry, I have some issues. There it says that uploads require you to log in, but I'm already logged in, so I don't know.
I have the same problem.
I think you did. I think you didn't log into the use Galaxy.eu. That's why you see that prompt. Try to re-log in, because if you don't log in, you can't use the tools. Because after you log in, they allocate some part of memory to your workspace, and without logging, it is no chance to upload your data. Please try to re-log in. Okay, so you have 3 jobs for uploading data here. we change the name of data sets based on a tutorial. Yeah, for example, here you can click on edit, this pen icon, and edit a name for this.
Could I ask something?
Yeah,
there are
please.
different versions of the tools. Does it matter?
Yeah, I will talk about. Yeah, so please change the name of these 3 data sets based on the material. Train rows with labels, and test rows. Okay. You see here in the training material, there are some tips, and if you click on a plus icon, you can see more details, how you can import data via links. Because there are maybe the basic steps in using Galaxy, after sometimes you will be do it without need any help. Whenever you forgot, you can click on this plus and see how you can upload your data via links, how you can rename the data set with this pencil icon, how you can change the data type. Sometimes you should change your data type because some tools using a specific data type as an input, and you should change the data type to the proper data type for the tools. For most of the machine learning algorithm, we use the tabular data type, and please be sure your data are tabular in this step. If you click here, you can see, yeah, this data set, the format is the tabular, so no need to change. But sometimes if you use, for example, comma separated values, you should you should change the data type. And you can see in the training material how can we do this changing. But here we don't apply it. So Victor, is there any problem again?
No, I have managed to upload them.
Okay, so
Yeah,
it's solved, yeah? After your real login, it's solved.
yeah, it's solved. It's just like
Okay,
I think I need to catch up.
okay. So let's see and what is inside these data sets. First, tell me, why do we have these 3 data sets? Why they are useful?
Because the first one to train the model.
Yeah, exactly.
The other ones you want to test, but one of them you know the labels.
Yeah.
The other, it seems that you don't know the label.
Okay, exactly. Thanks. Okay, we have 2 different data sets, such as train rows and test rows. You remember I told you should separate the data set into 2 different categories and use one of these splits to train and the other for your test. But here we have 2 different data sets, so no need to split it. But there is a tool in the Galaxy. If you have one data set, there is a tool for this split data sets. And you can say, for example, split data set 0.2. It means 20% of data set will be a test and the remaining 80% for the training. So you can use that tool, but here we have separate data sets. But for the evaluation, I want to know how good is my model. I want to have another data set with the real labels for the test data. So you predict the label, and then you can compare with the true labels to see how accurate your model. So we use these train rows to build a model, test to predict, and the test rows with label to evaluation, for evaluation. Okay? Is there any question? At the first step, we built simplest model. And I recommend you, please start with the simplest model in your analysis and see how it works. And then go further to the advanced models. The simplest one, you can use generalized linear models for classification and regression tools. You can find it here. Or you can just generalize. You can find it here in the machine learning part. Here, generalized linear models for classification and regression. And just click on it. You can see in the main page the parameter or input argument of these tools. When you click on a tool, you can see here the version of the tool. Some of them has older versions. You can see here the last version of tools is 1.8.2, but we have different older versions. By default, you will use the latest one. But in some tools, different versions maybe have a significant difference between each other. And as I told you, you can see some short description here for a tool. For example, a short introduction to a tool, what these arguments mean, and how can we use the data, and maybe the simple example for applying this data. Okay, so we start from this generalized linear model to build our linear model. We want to train a model because at the first step in machine learning analysis, you should build your model. Here we have load a model and predict, or train a model. At the first step, we should train a model. Which linear model you want to use? Here is the different linear models. Some of them are regressor for regression task, and some of them are classifier. In our case, we want to use this regressor. Why? Because we want to predict a real value. So our task is a regression task. And we want to use this linear regression model. Okay? And we want that the third part, we should select the input data as a training data. Let's back to the data and visualize them before we give it as an input to this training model. Let's see the data. We want to use this training raw data. If you click on this eye icon here, you can see the data here. Okay. Can you tell me about this data? Any idea? Any guess?
It seems that each line is a person, and
Okay.
each column should be a gene, something like that.
Okay. Each line is one sample. Can be a person or one person in different times or different cell of one person. We call it sample. So you have different samples here. Each line is one sample. How many samples do we have?
13.
209.
Yeah, you can see here 209 lines. We have 200 line, but one line is a header, not the sample. So we have 208 samples in this training data set. The first one is the header of the table. Any idea about the columns?
They look like genes.
Yeah, exactly. They look like genes, biomarkers. And the last column?
It's the age.
Is the age. So I want to find the mapping between the expression of the genes and the age of the cell. We call it chronological age. And using these biomarkers from the methylation data, because methylation is relevant to the age of a cell. And cell with the high age have more methylation and CpG sites inside. And we call it biomarkers, and of course they are genes. But if you ask me what do I mean by feature engineering, you can see one feature engineering here. We don't use all of the human genome here to this prediction. Some of them are important. Some of them are the biomarkers and more relevant to the age of a cell. And after this feature engineering, we just keep the value for these ages as you see here. And I want to predict the last column based on these features. So each gene is a feature, and you can see as a column in the training data set. So let's look at a test data set. Test data set have 105 lines, but again, the first line is the header, so you have 1.4 training data set. So around 33% is the training data, is the test data, and around 66% is the training data sets. So you will see here, it is with the label, and this one is without label. You have the genes, but no age column. And you should predict the age of this cell using the value for this gene and biomarkers. It is the aim of this hands-on. So we start from the or linear regression model. Again, in this where is my generalized linear model, I use train a model for this linear regression, and the input is tabular data. Which one is your training samples? The train rows is your training samples. Does the dataset contain header? Yes.
Yes.
We see the first line is header, so you choose yes. And How to select data by column? I mean the mapping. You want to map the genes to age, yes? So you can select columns by columns header name. But I want to choose all the column excluding age. Yes? It is a way to choose in the columns. By this option, I choose all the columns excluding age. And I want to map it to this label. What is my label? In the training rows, the last column or age column is my label, the age. Okay. I repeat it again. Here you want to say, do you remember I told about mapping between the X to Y? What mapping you should learn in this step? You should learn how we can map the expression of genes to the age. Where is the expression of genes? How can I select all the columns of a table excluding age? Okay, and where is the label for my this prediction? The labels again in this train rows, but where? In the age column. So select columns by column header name. The age color is your label, and this one is your age. So you can run it. It is possible here email notification. Sometimes maybe it takes long and you want to get a notification as an email so you can understand this job is finished. I will run it. Be careful about the case sensitivity. The Galaxy is case sensitive. When you use age, with capital A, of course. Yeah, here you can see the Galaxy statistics right now, which jobs are running at this time. Different jobs are running. Galaxy Q, number of jobs, number of tasks. Any questions so far? You see here, this is the generalized linear model and started to learn.
Sorry, for me it was just a bit confusing that we input twice the same table. Like I understand that it was because within the same table we had the labels, so we had to tell again that we had the labels within the same table. But does it happen that you don't have the labels within the same table?
Okay, I'll answer you. In our case, both genes and the age data are in one data set. That's why we use the same data set but different columns. For the genes, I choose all the data sets excluding the age one. And again, in that data set, I select the last column, age column for my labels. It is possible that you have data in different data sets, gene expressions in one data set and the labels and age in the other data sets.
Okay, thank you.
Okay, it's start running in the real workshop. Most of the time I give the stickers to the participant and they stick the green. It means done successfully, but here please, you can raise your hand maybe, so I can notice everyone completed this step. Okay. As you see in the training material, we have some question and answering. So the first question is, good, Nicholas, done. And I'm still waiting, so it is not a fair queuing. I started maybe sooner. So what is learned by the linear regressor? What are we learning right now? We are learning around a line. Curving, fitting is a line. So we are learning a weight for this line. If we write this line such as AX plus AX1 plus BX2 plus CX3, etc., we are trying to learn these coefficients for a line or weight. Machine learning tasks depend on a task sometimes as a time-consuming task. So please be patient when you use this ML tools. Mine is completely and successfully done now. If you click here, the model is the compressed zip file. It is a compressed zip file, and you can save this model. I'm trying to use exactly the same name in the training materials. Yeah, this is the linear regression model. So yeah, click on this edit attribute. One of this attribute is name. I just easily paste the name and save. So we build a model, the first phase of our machine learning pipeline. Okay. I'm waiting for the others to finish.
I have a red color here. And
okay. So for sure, you didn't set the parameters correctly. Please click if you want to see the parameter of your tools and which parameter you has tuned, you can click on this model. You see here, it is a, can you see here? It is run this job again. If you click on this icon, you can see the parameter of the model, arguments, inputs, and all. And if you click here, execute, you will rerun your parameter. In your case, for solving the problem, please check to see if all the parameters are the same as mine. Train rows, all column excluding this one, age, train rows, select columns by column header name. What was the problem?
I don't know exactly, but all the parameters were like at the beginning, not the parameters I put in it. But
okay. Okay.
Now I have the correct one.
So you didn't use it. For example, if you don't mention here the age, you will get a red color. And if you know the programming, you can handle it here. When you click in the view details, you can see the error of the tool. If you click here, it is successful. For example, jump information total parameters and the command lines and matrices. You can see all of them here. And even you can see the price here. This job costs for the Galaxy, European Galaxy server, it costs about 5 cents. Okay, so it is a cost of value, but of course it is free for you and for all the users, but it costs for us.
But this information is very interesting.
Yeah, and also the job matrices, you can see here the parameters. And if you face any error, you can see the error here, you can solve it. If you can solve by changing the parameter. And if you even, again, have a problem, you can report the problem to us. I will show you how you can report or help us. Okay. So we built a linear regression model now. I want to see not any more hand. Are you waiting?
No, here is finish.
Mine finished
Yeah.
first. I
Any
think that
problem?
was because I have an
Any
error.
problem? What? Sorry?
The mine that finished first, I think that maybe it was because I have an error.
Okay. So not a green color, yeah?
And
You have
it gives me green color, but when I try to download the zip file,
no, don't download the zip file. I will
but
see how.
I'm comparing my green box with yours, and mine says something like OMP info, and I don't know. It give me
Sorry, do you have a green box?
yes. I'm going to show the things that shows in my box. This. Let's say where you say using TensorFlow backend.
Okay.
Show me that. I don't know what is that.
Oh no, it is not an error.
No.
No. If
Oh.
no, it is not an error. If you face an error, you won't have a green job.
Oh, okay.
It is just a comment that about this process, about this job, because you use the I have the same using because you use the TensorFlow at the backend. It is more information to know how they build the model and what what tools in the Python used for running this model. It is the information, and also you use the scikit-learn, a well-known machine learning tool in Python to produce your model. Okay, let's go to the next part. So you build a model and you want to predict age using this test data set. Okay, and yeah, I want to predict using this model. Again, please go to this. You can rerun this tool. It's up to you. Or again, go to this category, find your appropriate model. As I told you, it is possible that you run your job again with the different parameters. So I try to rerun it, both the same. It is the prediction step. In the prediction step, you have your model, yes? Am I right? So you should load the model and do your prediction. What's your model? Right now, you have only one model in your history. So there is no other option. It is only the linear regression model. You want to predict age for the test data set. Yeah, am I right? You remember in test data sets, we don't have an age column and we want to predict the age for them. So the input data for the prediction part should be the test rows. Does the data set contain header? Yes. And I want to predict the class labels again. And now I don't need any notification, so I just execute. Again, we load the model, linear regression, test rows. It contains a header, and we execute to see the results. Again, it's great. Waiting to start.
Sorry, what did start? So what did we get to? It seems to be a matrix, like a dot that was the result for the linear regression model.
No,
but it's a zip file, so I cannot see.
No, we will the tabular file with the extra column, predicted age.
Okay. In the linear regression model, that's the.
In all of them, we have this
Okay.
we want to just predict the last column, the age column, but with different models. It is same if you use linear model, nonlinear, such as ensemble methods.
Yeah, but how does the model looks? That's my question, because it just says compressed zip file.
The model is only the parameter. What do you mean? In the linear regression, it is the coefficient of a line.
Uh-huh. So
And
it's like a matrix?
No, not a matrix. Just it is saved and for example, as a JSON component, and
Okay.
maybe it can be a zip file. And in this case, it is the compressed zip file.
Okay. Thanks.
The model is not a data. It is a mapping. It is a function. And you want to have only the parameter of this mapping function.
Okay.
Okay, so here you see we can rename it to the predicted data linear. Same as here. After I do this prediction, we can come here. The name is predicted data using the linear approach. Let's have a look at the result. Yeah, cool. You have again the features. And the last column is the age. And you see it is a real value. And you compare this age with this, for example, true labels. If you click here, you can see both of them together. Again, if you want to visualize two tables and compare them to each other, please click here. It is a scratchbook. If you click on this scratchbook and go to the test rows with labels and view data, you can see the new data sets in this column, in this window, sorry. So the last one is the age, for example, 40, 44, 28, and you can see the predicted one here, 46.68, 46.09, 29.58, and it is the true value. And we can use this true value to evaluate our approach. You did the prediction. We use this true value to predict, to evaluate the result and maybe visualize, and I will introduce some visualization too. But the important point, when you see the test rows with labels, it has header, but my result does not have any header. So first, in order to compare the result with the label data set, I should remove the header from the test row labels. So both of the data set, both of the tables does not have any header, and I can compare them easily and visualize the results. Okay, so here in the visualize the prediction, you see I first remove beginning of a file. I mean the header of a file. There is a tool in Galaxy I can use for removing beginning of file. For example, in tables, you can remove 5 samples or 1 sample. If I remove 1 sample, it means I remove the header. So remove. Unfortunately, sometimes finding the, for example, the remove columns, I want to show you another tools. You see the difference here. Sometimes searching is not as easy as you imagine, and we are working to improve it. But there is a good option here. If you use a tool, I will show you how you can use this option. Oof. I don't know why I have a problem in my, let me refresh it maybe. Oh yeah, it is in the text manipulating, and I can find this. Yeah, remove columns, remove beginning. Okay. Oh yeah, here, remove beginning of a file. It is in the text manipulating part. You can use these tools, but it is not so much intelligent search. But I recommend you, if you are using some tools in your analysis, for example, this one, you can add it to your favorite tools. If you add to your favorite tools, for example, I have here my favorite tools, instead of searching among the dozens of tools, you can easily go to your favorites and select your tool from here. So, for example, if you are doing RNA-seq data analysis, you can add the RNA-seq tools in your favorites, and you can easily find from your list instead of searching from the other categories. In this remove beginning, I want to remove the first line from this test rows label, and yeah. Just click the execute, and it's still running.
I have a question.
Yeah, please.
When you choose how to select the data with the all columns, either excluding or including the header name, and then we have to type age, is it case sensitive?
Yeah, it's case sensitive. Yeah.
Okay.
Yeah, with capital A, please. Or there are different ways. I will show again. We will use this tool. I will show you. There are other options to select the columns by index. In our case, the table has a header line, so we can easily select the columns by header. But if you don't have any header, you can select the columns by index. For example, 1 to 10. Okay. See, here we remove the test. We remove the header with test row labels. I rename the table to test rows labels without header. And if you see the table, it is the same one, but I removed the header. So you can use this tool for removing any samples, whatever you want from the beginning of a file. Of course, there are other tools you can find in the text manipulation. For example, if you want to remove one column from your data sets or specific rows from your data sets, there are some text manipulating, which is very useful in your pre-processing step to for example, produce your clean and impute the missing values in your data sets. Okay, so I have the test row labels and predicted data linear, and I want to evaluate my prediction by visualize them. The first tool I want to show you, and you can find it in the machine learning category, is this, where is, yeah, here. There are some tools for visualization. One of them is plot actual or predicted curves and residual plots. You can search it by this residual keyword, and yeah, here, plot actual with predicted curves and residual plots of tabular data. Or you can find it here from your favorite. As I told you, this search is not that smart, but we are working to improve. Yeah. You see, you will find two of them. One of them is the first version. Oh, no, both of them here. Yeah, it is the same. You can use it easily, yeah. But sometimes we use tests, some tools in these test tools. And you can find, for example, some tools here for support vector machines or the other tools. It means these are not reliable tools, and we are trying to test it, and after it will be no error and be more reliable, we move it to the to another category. But in a test, I recommend you don't use the test tools. They are for testing part. But here in the machine learning and statistics, you can see the last version of tested tools. And for the visualization, you can find in the statistics different visualization tool, plot actual predicted curves. We are gonna use it now and plot confusion matrix, and you will see that some heat map, for example, for visualize the heat map of the matrix data. But here in the statistics, please choose this plot actual and predicted curve and residual plots. So here I select the input file. Input file is the test rows labels without header, and select your predicted data file. If you remember, after you done your prediction, we renamed to predicted data linear. So your prediction data file is predicted data linear. And I want to compare these two tables together and visualize the result. It is the first visualization tool. Okay. So you see here the output of this visualization part. Yeah, here is the true versus predicted values. These samples have two dimensions. First is the true value, the second is the predicted value. If your true value be the equal to the real value, this sample falls to this line, to this curve, x equal to y curve. In the good regression, most of your samples in this visualization chart should be near to the curve. And in the ideal regressor with the performance 100%, all of these samples fall onto this line. So please, this is important. This curve is not a regression curve. It is x equal to y curve to compare the predicted values and true values. So you can use this output as a result in your analysis. It's possible to save it, to edit it, to download as a PNG file, as an image. And yeah, you can save it and import in your document, in your reports, or in your papers. And this is the scatter graph.
Sorry, should my graphs be identical to yours? Because they are not, and I'm afraid I did something wrong. They are not bad, but they are not identical.
And yeah, they are not bad. Yeah, I will talk about the results, but let's first see what does it mean. It is the predicted value and true value, and you can see the difference between the predicted and real values in all of the data sets, 104 data set that you have. Yeah, it is a prediction. It is not a bad prediction. You can see the results. For example, if your age is 46, we predict 46.68. It's not that bad. For 28, we predict 29, around 29. But we use the simplest model, a linear regression so far. But And here you can see in the residual plot, see here the actual and predicted one. Sorry, yeah, this is the actual and predicted. You see, yet you see here the true and predicted targets. Here in this in this graph, you can see two measures. First one is RMSE, means root mean square error. It is the error measure between your true values and the predicted values, and it is 4.1. Lower means better regressor, minimum error, less error. And it is the coefficient I introduced in the training material, and if it is close to 1 or 2 score, it means you have the good regressor, and in the ideal regressor you will have R2 equal to 1. So we have, as we can see, at least 2 measures to compare the 2 predicted values to the true values, and of course 3 charts. And this chart is also the useful. It is the scatter plot. I have a link in the training materials. What does a scatter graph mean? But for the simplicity, I can tell you, if you see random distribution between the nodes in the residual graph, it means you have a good regressor. But if you find some patterns in these samples, it means it is not good, and there is a pattern here, and the error is not a random error. So we should think about how we can improve it. Okay, so done. You predict whatever you want. You wanted to predict the age. So you know how build your model, machine learning model, regressor model. Of course, you tried so far simple linear model, so no parameter tuning needed because it's a simple and we use all the default parameters, but at least you can predict age with this error rate, with the root mean square error around 4.1 and the R2 score 0.93. In the next step, we will talk how we can improve these accuracies by going to some advanced regressors. So far, we use the linear regressor, so it's learned the linear mapping between the genes and the age, but it is not a linear function. The mapping can be a non-linear relationship between the genes expression and the age of a cell loop. And we will introduce another model to capture and model this non-linearity and compare the results with the first one. Okay, I think it's a time for the break. I can see from your eyes and stomach maybe. So break.
I'm sorry, I have a question.
Okay.
In the residual plot, it seems like about 50 years is more difficult to get the accuracy. You could say that, or
let me please. Would you let me please refresh this? Yeah, it is the actual and predicted value. Yeah, this one. And here the scatter plot. Yeah, and this is the residual one, the 3. Which one do you have question about? Which of these?
with the residual.
Yeah, this one, yeah.
Yeah.
Okay. If you can't see any pattern in this points or samples in the residual space, it means it is the error is random. So you have a good regressor.
Okay.
It is not about the accuracy. It is about randomness of an error in estimation. But if you find the pattern, it means, oh, I am not good in, for example, predicting the age above 40. So I should solve this problem and go back. Why this prediction is not good for above 40, but it is very, very good and with the high performance for the age below 30. If you find the patterns here, you can get a feedback to improve your maybe data, maybe you don't have enough data to learn the model, and it is a feedback for improving your data set and analysis. It is not about the accuracy at all. It is not about the error. Just see if it is randomly distributed or not.
Okay. Thank you.
Okay. So